Now let's look at another example. Let's look at x squared minus 8x plus 3 is equal to 0. The quadratic equation is already in standard form. The right member is 0. The left member is in standard form. It's in descending order. X squared, x to the first, and then the constant. Now what I would normally do is to try to factor this, but it won't factor. To get x squared I could use x and x. To get 3 I could use 3 and 1. But any way you try to use the combinations, you are not going to get 8. So therefore it will not factor. What I can do is to make it factor on the left side and use my principal root method. So my first step is to add a negative 3 to both sides. If I add a negative 3 to both sides, I get x squared minus 8x is equal to a negative 3. Now I'm going to make this left side factor. I'm going to make the left side factor. The way I'm going to make it factor is to make it a perfect square. I can do that by taking half of the linear term and squaring it. So I can come in here and I can take 1/2 of a negative 8 and then square the whole thing. So if I take 1/2 of negative 8 and then square the whole thing, I get a negative 4 squared, because half of negative 8 is negative 4, and a negative 4 squared is 16. So I get 16. I'm going to add that 16 to both sides to get x squared minus 8x plus 16 is equal to a negative 3 plus 16. Now you might be wondering, how did I know to take half of negative 8 and square it? Well, that's by observing that all squares have that particular pattern. But I'm not interested in you seeing that. What I want you to do is to see that what I have done is mathematically legal. All I have really done is added 16 to both sides. I added 16 to the left side, I added 16 to the right side. So I added 16 to both sides. And of course, that's legal. Now notice what this 16 allows me to do. I can factor my left side into x minus 4 times x minus 4. X times x gives x squared. This will be a negative 4x plus a negative 4x, which is negative 8x. Now that shows you why you had to take half of it up here, because in multiplying it back out you're doubling it. And then a negative 4 times negative 4 is positive 16. So I can factor my left member into x minus 4 times x minus 4. Of course my right member is going to be a negative 3 plus 16, which is 13. I can write x minus 4 times x minus 4 as x minus 4 quantity squared. So therefore I have x minus 4 quantity squared is equal to 13. So I have something squared is equal to a constant. Now I can use my principal root method by taking the square root of both sides. If I take the square root of x minus 4 quantity squared, I get x minus 4. And if I take the square root of 13, I get plus or minus square root of 13. Remember, the principal root theorem tells you that you will have the plus or minus, so be sure to put it in. Now to get x by itself, all I need to do is to add a 4 to both sides. So I add a positive 4 to both sides to get x is 4 plus or minus the square root of 13. So we have solved a problem that we could not solve previously. We can solve it by completing the square. Now this is called completing the square. So when you take half the linear coefficient and square it and add that to both sides, the process is called completing the square. So we have x is 4 plus the square root of 13, or x is 4 minus the square root of 13. Now pull out your calculators and evaluate that. So I'll do the first one for you. So I can do 4 plus the square root of 13 equals 7.61. See, 7.61 when you round off. So I get x is 7.61, or x is approximately 0.39 when you do the second one. I won't do the second one since I've shown you a couple times how to do it on the calculator. Now it's time to give you a couple more exercises. Solve for x and approximate your answer to 100th. Solve for x and approximate your answers to the nearest 100th. The first one, x minus 3 quantity squared minus 5 is equal to 0. The second one, x squared plus 2x minus 5 is equal to 0. Now you can solve these two by following exactly the same pattern that I did for the two previous examples. So you may want to go back and look at your notes and follow your notes carefully as you solve these two problems. Copy down the two problems, stop the tape, work the problems, and then restart the tape to check your answers. Here come your answers. If you disagree with either pair of answers, be sure to check with someone. One can combine the two methods previously discussed to solve certain higher order equations. Here we have an equation of the fourth degree. I can rewrite it as x to the fourth plus 3x squared minus 4 is equal to 0. I simply subtracted 4 from both sides. I can factor this one as follows. Now to get x to the fourth, I can use x squared times x squared. This tells me my signs are going to be different. So I'm going to have one negative and one positive, and I need to get a positive 3. So I think I can use a 4 and a 1. Now let's see if that works. X squared times x squared is x to the fourth. 4x squared minus 1x squared is 3x squared. And a negative 1 times a positive 4 is negative 4. Now we can have x squared minus 1 is equal to 0, or x squared plus 4 is equal to 0. So I started with a fourth degree. By factoring, I got down to two second degree equations, or two quadratic equations. I can use the principal root method to solve these two. I can get x squared is equal to 1, so x is equal to plus or minus the square root of 1. Over here I can get x squared is equal to a negative 4, so x is equal to plus or minus the square root of negative 4. Here I have x is equal to plus or minus 1. Here x would equal to plus or minus. I can write this as the square root of 4 times the square root of negative 1, which would be 2i. So we get four answers. X is equal to 1. X is equal to a negative 1. X is equal to 2i. x is equal to a negative 2i. If you start with a fourth degree equation, you expect four answers.